Okay, so we're looking at 6.3, interpreting sinusoidal functions. And I'm going to go through example 1 and 3 for this handout. We do have to remember a couple things. So circumference of a circle is 2 pi r, and speed is distance over time. So you'll see why in a second. In example 1, two people are riding their bike. A pebble is stuck to each tire on the bike. The two graphs show the height of the pebble above the ground in terms of time. So the black line is bike A, and the red or whatever pink line is bike B. It says, what's the equation of axis and what does it represent in this situation? So the equation of axis is the middle of your sinusoidal function. So if this is the sinusoidal function, the midpoint, if that's 60 and 0, the midpoint would be 30. So the equation of axis for the bike A is height, or I'll just say y, is 30. For bike B, if the maximum point is 50 and the minimum is 0, that'd be 25. So what does that represent in this situation? It's the middle of the tire. So whenever you have something circular, like a tire or a Ferris wheel or a windmill or whatever it is, it's the middle. So this is the axle of the tire. Okay, so that center point is what it's representing, the middle of the circle. You could also think of it as the average height, because it passes this height twice. If there was a rock stuck in here, right, in the tire, or here, whatever, it goes up, it's at the middle, it goes back around, it's at the middle again. So that happens twice in each rotation, or in each period. So that's the average. What's the amplitude, and what does it represent? So the amplitude is the distance from the middle to the top, or the middle to the bottom. So if the middle's at 30 and we're going up to 60 for bike A, the amplitude is 30. And for bike B, it would be 25. So it's not always equal to the equation of axis. It just happens to be in this situation. Or basically whenever the bottom is at 0, the equation of axis and your amplitude will be the same. So in this situation, it represents the maximum, the distance away from the axle. From the axle. And the maximum height and the minimum height from the axle. What's the period? And what does it represent? So it's a little hard to tell from this graph, but if we have 5 sections, one has been changed to 5, so that would be 0.2, 0.4, 0.6, 0.8. So we look for the point that's repeating in each sinusoidal function. So if I go from the top to the top, right, because that repeats, you can see that is 0.6. So you could pick any point, and you go from there to there and measure that. So as long as you go from the same point in the cycle back to that same point and measure the distance between them, that would be your period. So it's easy for me to measure here because I can actually tell what those points are. So that'd be 0.6 for bike A. So in this case, it's measured in seconds. And bike B, we're going to here, so halfway, so 0.5. Okay, so for bike A to go from here, so 60 centimeters, down to 0, back to 60 centimeters, took 0.6 seconds. So that is from the maximum height down to the minimum, back to the maximum. So what's happening is the tire is turning. That's the time it takes for one rotation of the tire. Okay, so the period in this case is the time for one rotation. Which bike is going faster? Okay, so we need to figure out the distance over the time. So we have the time, but we don't know the distance. So the distance that the bike is traveling is the same as the circumference of the bike. Sorry, not the bike, but of the tire. So the circumference is the distance traveled in one rotation. So for bike A, the circumference is 2 pi, and then r is the same as the radius, so that'd be 30. So that's 60 pi, and I'm going to leave it as 60 pi. So now we can figure out the speed because it's distance divided by time. So the distance that it travels is 60 pi, and it took 0.6 seconds to do that. So if I divide this, I need to get the calculator out. Pi 314.16. So bike B is 2 pi times the radius, which is 25. So 50 pi. So it travels 50 pi centimeters or whatever it is in 0.5 seconds. So that will be 50 pi the same thing. So their speed is the same. Okay, so if we go back up here, and if we were in class together, we'd have a whole discussion about this beforehand. But you might think that bike A is faster, or sorry, the pink one is faster because it looks like it's doing more of it, but it's not. It might be turning faster, but because the wheel is smaller, it's not going as fast. So picture this. My bike would have regular sized tires, but my 5-year-old's bike would have very small tires. So she's pedaling and spinning her feet as fast as she possibly can, and I just have to do like 2 or 3 pedals and I've gone the same distance, just because my tires are so much bigger, right? So even though I may not be turning my tires as much, doing as many rotations per minute, because my tires are larger, I'm traveling the same distance as my child's tiny bike is going. So don't get fooled by the sinusoidal graph pictures and period and stuff. We got to actually calculate to see who's going faster. And in this case, they're both going the same speed. So the distance away from the axle, the amplitude, is always the radius. So the equation of axis is the middle of the tire, or the middle of the thing that's spinning. The amplitude is going to be your radius. The period is the time for one rotation of whatever it is, the tire, Ferris wheel, windmill, whatever it is. Okay, so example 2 is the same thing. It's just a saw blade instead of a bicycle tire, but it's the same thing. So example 3 says to sketch a height versus time graph of the sinusoidal function of a Ferris wheel with a radius of 10, whose axle is 12 meters above the ground and rotates every 30 seconds. So draw 2 cycles. We're just going to get a sketch here. But let's think about this. So if it has a radius of 10, that means the amplitude is 10. And if the axle is 12 meters above the ground, that means the equation of axis is y, or h, is equal to 12. And if it rotates every 30 seconds, it means our period is 30 seconds. So we're going to get a sketch of what this looks like. So what I like to do is sort of map out what the graph is going to look like before I actually graph the map. So I know that my equation of axis is at 12. So I will mark off 12. And you can draw a dotted line, because that's where the middle point is going to be. Now, using my amplitude, I'm going to figure out my maximum and lowest point, or minimum point. So amplitude is 10. That means the highest point is going to be 22, and the lowest point is 2. I also know that the period is 30 seconds. So I'm going to put it halfway because I want to do 2 cycles. Okay, now every sinusoidal function looks the same. It follows the same pattern. So it's not going to be, something like this, because it's not symmetrical. So what I'll do then is divide my period into 4 sections. Middle, and middle again. All right, so you divide the period by 4 to get what your 4 sections will be. So first I divide by 2 and then divide by 2 again. So this maps out where everything's supposed to go. I just haven't actually plotted it yet. So because it says draw 2 cycles and start at the lowest possible height, I'm going to start at the lowest possible height, which is there. So in the first quarter of my period, so 7.5, I'm going to go from the lowest point to the middle point. And then in the next quarter, I'm going to go to the highest point. And then I have to come back down. So the next quarter here, next quarter. So this is my sinusoidal function. So it's an upside down cosine function. And then that would just get repeated again because it's periodic. So that is a sketch of the graph of a Ferris wheel. Okay.